All right, so I wanted to show a couple examples here of how to clear fractions while we're working equations or linear equations. And the key word here is linear, right? So I've got another example we're going to work through. And here it is. I've got 1/4 times the quantity of p plus 3 minus 2/5 times the quantity of p plus 1 is equal to -1. Here again, I need to identify a couple things. The first one is how many terms do I have in the whole thing? I have one term there because a term is a constant, it is a variable, or it is a product of a constant and a variable. Because these two things are being multiplied here, butted up against each other, the parentheses makes this one thing, butted up against each other makes it one thing because it's being multiplied by the 1/4. So I have one term there. Here's my second term, and on the other side of the equation I have that term. All right, so there are three terms sitting there. So we have to find the least common denominator or a common denominator between all three of those terms. So I need to find a least common denominator. In this case, it's just between the denominators of 4 and 5, which is 20. So what do I do with it? Well, I'm trying to eliminate my denominators. So I want to build this fraction big enough to where my denominators leave. So I'm going to take the left side times 20 and the right side times 20. This number that I found here of a common denominator. And what that's going to do is that's going to build me big enough to where all my denominators leave me and I'm left with the same equation, just linear. So when I distribute this, yes, I distribute it to this term, but I don't want to take it to the parentheses. It can, but the whole reason for me to do that is to get rid of this 1/4. So I really don't want to do that. I want to do it to this guy. So 20 over 4 becomes 5, and it becomes 5 times the quantity of p plus 3. And don't distribute it to this guy and that guy, okay? Because then I've really distributed 400 to that problem because it's all multiplied. It'll all come back in the middle anyway. All right, so once I've got that, then I minus, distribute the 20, and remember, I want that fraction to leave, so minus, this will be 40 over 5, and 40 over 5 would just simply be 8, p plus 1. But what I do to the left side, I got to do the right. And yes, it doesn't matter that that's not a fraction. We still got to make it equal. So we do to the left what we do to the right, and this becomes -20. And now I've got this guy that's linear, no fractions, and a lot of people would rather work this guy. So let's go ahead and finish that guy up. So I have to simplify the left side. So I get 5p plus 15. Distribute this. So I get minus 8p. And don't forget, is it subtraction or is it a negative? That answer is yes. So add the opposite sign, distribute it, you get -8p. Distribute it again, you get -8. Make sure the sign goes with it. And I'm just going to filter this guy down. Combine like terms, and I get -3p. Combine like terms with my constants, and I get plus 7 equals -20. Add my 7 to both sides, I get -3p is equal to -27. A little bit more. Whoop. I missed. How dare I? I missed. Divide by -3, and that leaves me with p. Divide by -3, and a negative over a negative is a positive. 27 over 3 gets me 9. And there's another example of how to eliminate my denominators by using a least common denominator, rewriting each fraction as equivalent, each side of the fraction as equivalent, and get my answer. And last but not least, if I want to know that's the right answer, plug it back in. When you do, plug it back into that guy. That was the original problem. Left side equals right side, and I have the right answer.